Okay, perfect. Thank you. All right. Welcome everyone to this OWASP session. We're going to talk about GitHub Advanced Security. My name is Sanja Meric, and I have three of my colleagues from OWASP here. Shane, you can present yourself, guys. Davis and Sebastian. So this session will be about 1 hour, 1 hour, 10 minutes long. And this will be streamed as well. And my colleagues here will help out with the chat. For the questions, we're going to take them afterwards, so everybody can have a possibility to get their questions answered in a good way. Session is in English, and I will be going through GitHub Advanced Security, how to configure it, and how to turn it on both private and public repository. Sorry, it's not okay. Then we have a technical issues, as it should be. I mean. Where are we streaming? Good question. Okay, shall we try to configure that? Davis, can you check if you can? So we're gonna give it a couple of minutes if we can solve it. That's not me. It's a yes. It's a wrong key. Can you? Oh. Well, good day. Well, I can ask you guys kind of, are you working with security in organizations or developers? Kind of, what are you seeking with this session? Just knowledge? Developer? Yeah. We're gonna talk about shift left and kind of how to this can help. DevSecOps, that's DevSecOps as well. Yeah. Then good crowd. I'm myself is I'm a DevSecOps guy, and I worked with Azure DevOps GitHub for a long time, security wise as well. So anyway, yeah. Okay, so it seems to work, and that's almost. So it seems to work, and I think we can. Yeah. All right. Good. Okay, so let's start a bit. Session is a bit over an hour, and there will be also time for the question answer and discussion afterwards. Let's start. So my name is Sanja Miric. I'm head of development at Solidify, I'm also a principal architect and work with customers adopting DevSecOps in a good way, working with security related questions. And together with the guys here, I'm also OWASP chapter lead for the Stockholm area. And today we're going to talk about advanced security. So I work with developers daily. I am a developer myself. I still code, not as much I would like, but still. And this is something I have thought about a lot about. So we have developed the software for a long time. We write new features daily, weekly, and we are also kind of mentioning vulnerabilities. But if you look at the statistics you see in the stream, it's still number of vulnerabilities is increasing. So each day. So even we thinking about it, even if we are writing more code and we are actually having security, static analysis tools and so on and so forth, we still see that we are not improving that much. Now, okay, more code, more errors, of course, but because we are already working on it, it should be better. And if we look at the vulnerabilities, so the flaws in applications are consistently number one attack vector in our applications. And at the same time, when we develop, we use a lot of packages. So a lot of code that we actually put in production is not our code. It's maybe 20%, maybe 25% of the code is our own. Rest of is dependencies, or the code that we have borrowed from, like Stack Overflow or something like that. So a lot of code is not even ours. So this is the vulnerability part. And if you look at the security part or the secret part, it's as dark. So since I don't know how many years we start working with key vaults, both in the cloud and in our servers, and there are many different ways on how to actually protect the secrets and not use them and not commit them in the repositories. But this is statistics. This is a GitHub statistic that they have, and they have seen that from December 2018 to August 2021, we have 50% increase in the GitHub secrets committed to public repositories. So this is big. And when we look at this type of statistics, they are usually searching for very specific secrets. If we look at this, things like connection string and other secrets that are not easily found, it's even worse. And remember, we do have tools on how to do it properly, but many of those mistakes are not they're just mistakes. I mean, people have a Friday afternoon, they want to go home, you do a commit, mistake happen, and now your secret is in the repository and needs to be rotated. And we all know how often we rotate secrets. Not very often, unfortunately. So we need to start shifting left the secret part. And we have started doing that for a while. I mean, this is the image we have probably seen 1,000 times before. So it started like for 12 years ago, we started off shifting left the builds, shifting left deployments, shifting left testing, and so on and so forth. Now we're going forward and shifting left security, and we solidify, we see that even in the future, we're going to shift left other things as well, like compliance and other relevant things in development. So what is interesting with the shift left in security wise? Well, first, when we come to the vulnerabilities and threats, and if you get hacked, the breach, the cost of breach can be enormous. So just for bugs, you have a certain number, and for breaches, there is basically no limit. And we have seen this for a couple of last years. So huge numbers and a lot of issues when if you come to the situation you get breached. Now, and by shifting left security, we are fighting with another thing. It's knowledge. So in many cases, you need specific knowledge on how to code properly, securely, how to utilize tools, how to actually get this working. And the professional developers contra the people that are security researchers, we outnumber them 570 to 1. So 570 developer for one guy that's actually looking and finding new vulnerabilities out in the code. And this is just typical. So what we need to do is we need to make sure that we can use that knowledge that they have and automate it somehow in our pipelines, that we can do those scans without having that as full-time job. So this is something that when we look at the DevSecOps part of things, this is where I see GitHub Advanced Security with this amazing solution. And why I like it so much, it's because it's so close to me as a developer. I have a code scanning, I have a secret scanning, I have overview parts, and I have a supply chain or Dependabot protection, and everything is in the tool that I use daily. For pull requests, for commits, for communication with my teammates, it's there. It's something I use daily. I don't need to jump out to another tool, look there, and then go back to my code. It's integrated. And that's what we see in the core structure. It's developer first. It's native to the environment, and in many cases, it can be automated. So I don't know if you have to turn that on your repositories, but like if you have a automated, Dependabot can actually automate the pull request for you. So creating a pull request, and that just that tiny little thing is it helps. Personally, I like to get my pull requests clean, so pull request lists, and that helps me enormously to make this number one priority for everybody. So we're going to go through first Dependabot, then we're going to go through code scanning, or sorry, secret scanning. Then we're going through code scanning, and at the end I will go through features that you can see for an organizational level, how to get an overview of how your organization, health of your organization when it comes to secrets and vulnerabilities and so on. I will do demo on a private repo, so just so you see the difference. But on the public one, there are some smaller differences, but in many cases this is so free. So for public repository, GitHub Advanced Security is free. For the private ones, you need to have a license for it. All right, so dependency scan. So as I mentioned previously, we have this as our application. So we have our own code, and to get that to work, we're using a lot of packages. And those packages are using other packages and so on and so forth. So we have this huge dependency chain, and this can be deep. And I have in the demo, I created basically boilerplate application, and I have over 1,000 packages dependencies for just backend, front end, and couple of kind of item services. So what happens here is if we download the code and start using a package from somebody else, and we use that in production, we don't know who actually created this package. We trust some random developer from the internet, and we trust them because I don't know, we don't have basically reason, but he has developed something that is good. A lot of people are using, maybe. Okay, fine. But still, if they get vulnerability in their package, this can be then chained and can be exposed in our code as well. So mistake in our dependency chain line can affect our code as well. So this is where the dependency scanning and Dependabot is doing good job, great job. So first, we have this thing, just a dependency graph, which is basically representation and the view where we can see all the dependencies that we have in our application. So we're gonna see versions, we're gonna see I'm going to show you in a demo. You can see basically everything and also the licenses. And then we can have a dependency insights as well in the same view. And when we start on managing our dependencies, when we will, I will show you how we get the Dependabot alerts, just to get the warnings about there are vulnerabilities in our code. I can show you how you can turn out Dependabot security updates and Dependabot version updates. So the security updates will automatically create pull request for the vulnerable dependencies packages, but Dependabot version updates will actually create pull requests just to increase the versions. So a little bit of housekeeping in your code, basically, not letting your code go to legacy too early. When doing this dependency review, I will show you in the code. It will scan licenses. You can get the feedback in pull request. So basically, get it in build. And if you get a pull request with dependency that has a vulnerability, you can adjust the tool so it actually rejects your pull request. And you can also review dependency in there. So I will jump out and I will go to my application. So I have this application, which is in our GitHub. Let's see if I can open Solidify demo. Did I? Oh. Present, share screen. Better? All right. So I have this application here in just the clean application. I have a backend, which is .NET. I have a frontend, which is React. I have a couple of infrastructure as a code structures when I use Terraform. And of course, backend, it's the container. So I have a pretty typical setup that we have. And right now we have a GitHub Advanced Security turn on this organization, and but I have not configured it for this repository. So what I do is I go to settings, I go to code security and analysis, and here I can turn on Dependabot features. I can turn out GitHub Advanced Security. So let's start by turning on the Dependabot. So with the first one, I will actually get the Panda Bot alerts. So in the security tab in my repository, I will get the list of all vulnerabilities I have when it comes to packages. Next one is turn on Dependabot security updates. If I do that, the Dependabot will automatically create pull requests for me for the vulnerable dependencies, which is great thing. And last thing here is Dependabot version updates. And for that to enable that, I need to configure a YAML file to actually configure it. So before I do that, I can show you. So right now, I can go to my security, and I can see in the Dependabot, I see I'll receive some vulnerabilities in my packages. And this is just by default. This is almost boilerplate, straight from the box. So there are a couple of high ones and one moderate ones. And with the vulnerabilities, I can select the package. I can select the ecosystem. Right now, it's npm 5 npm 1 NuGet. I can get the severity and filter on severity level, and I can sort differently. And of course, I can switch between open ones and the closed ones. Now, with vulnerabilities, what you have seen here, when I open one, I can actually see the details about it. So I can see explanation, I can see which version are affected and which version it's patched in. This has been patched in. I can see CVSS matrix and the data there. And I can, as a power user or user, I can select to dismiss alert. In some cases, vulnerability presented is nothing that's going to expose my code or be vulnerable. So there are a couple of things what you can choose here to do is like, for example, I have no bandwidth to fix this, or this alert is inaccurate or incorrect, or vulnerable code is not actually used. So I can put some to comment and I can dismiss it. So if I say like this, okay, then see, and I can dismiss it. So this vulnerability is now dismissed. And if I go to security and Dependabot again, now I can see I have one dismissed. So it has not disappeared. It's still here. Now I strategically choose one with pull request. But what I want to show you is actually I can reopen this one. So if I have closed this by error, or if I realize later that this indeed is a problematic, I can reopen it anytime. And in the vulnerability, in the warning, I can see list of logs, what happened, who did what. And as you can, as you saw now when I opened the first one, there is a pull request associated with this vulnerability. So the Panda Bot created a pull request for me, and if I go there, I have arrived to this pull request, and you can see there is detail about the vulnerability. And this is another great thing with the Dependabot. Basically, it gathers the information for all the repositories, public ones, and gives me a metrics on how many updates like this have actually gone bad or good. So in this case, 100% of people bumping this automatically have actually passed builds. So in my cases, in my experience, this is a good number to follow. So if I see 100%, if I see basically 90 plus, my own experience, it's usually quite okay. So in this case, I can test it. I can maybe merge it, maybe confirm merge, and now this will be written to my code. Another thing what we can do with the pull request already open is we can actually communicate with the Dependabot. In some cases, we don't want to update a minor version right now. We want to wait with it and open it later. And for that, how we do that is by writing chat messages to the Dependabot. And if you go in the comments or in the comment for the pull request, you can see commands and options. And in here, you can choose to recreate pull request. You can ignore a minor version, major version, skip one, whatnot. You can actually rescan it altogether. So this is a great way for me to communicate. Just kind of tell the Panda-bot, yeah, I'm not gonna bother right now. Let's wait for the next version. For some reason, of course, it's usually developer that knows the best how their code works. So those are the pull requests, so alerts, and also creation on pull request. And what I want to show you is dependency tree. And this is the only thing not in security, it's under insights. So if I go to insights and go to dependency graph, I can actually see first it warns me that it found dependency vulnerabilities in our dependencies. It marks them, and here I can actually see the number of dependencies I have, and I can go in to this chain and continue for all eternity, just kind of drilling down package after package after package. So this is a image usually that scares me, because the how much of the packages we're using without even realizing it ourselves. Another thing that I want to do now is I want to turn on the version updates as well. So the same time I get the pull request for the vulnerable packages, I want to get that as a housekeeping task, as help to update the versions. And to do that, the same thing again, go to settings, code security and analysis, and then enable Dependabot version updates. So what happens is GitHub will create a boilerplate for us, and will create a Dependabot YAML file under .github map folder. So right now, let's just accept it as it is. So need to do some change here, and just commit new file. So this is the suggested Dependabot YAML, and if this is okay, what we will see the number of pull requests going up. But I'm not sure if this is configured correctly or not. And one way to look at if configuration is correct is go to Insights, once again, Dependency Graph, and we can go to Dependabot. And this should be updated. I think so, but I think it should be if it's not that slow. I think it's because I renamed them. We'll see. Let me configure it one more time. If sorry. Oh, zoom it. I can do that. Is it better? Oh yeah, this is a big room. Just tell me. I will try to increase the font even more. So once again, if I go to, oh no, it's so small. So let's go to Insights, Dependency Graph, and Dependabot. And I think it's just slow to actually pick it up. Yeah, I saw that as well. So that's, but it should actually do it with change. So there's no build because it's not actually an action. It's just a configuration file for it. So not really sure why it is happening. However, I know that I misconfigured it. So Dependabot YAML right now is looking under the root directory here. And if I go to my root, there is no packages here whatsoever. So I need to actually, going to Insights and Dependency Graph and Dependabot, that will actually show me, right now I honestly don't know why it's behaving like this. It will show me kind of what's happening and where the error is. So what I need to do then is go to OSP, GitHub, Dependabot, and I need to edit this file. And I already prepared this. So this is the Dependabot file that is working for me. And I can explain it when I turn it on. So I want to update Terraform for this directory. It's one of the directories in my application. I want to do it daily. The same thing with Terraform, but in other directory. Docker on the backend. I have a NuGet on the backend as well. And I want to update package ecosystem for NPM on the front end. So quite simple, and I also can instruct it to prefix my pull request in some way for maybe not doing some builds. I can choose to limit how many pull requests I want to have open. So everything is you can configure it quite a lot. So I will commit this, and if I go to settings, I can show you code security and analysis. Can show you here when you go to the links, and GitHub is linking to the documentation page directly, and you can read about which settings you can use which intervals, and also some other metadata. Open pull request limit. You can have version specific ones and so on and so on. And you can specify your own package managers as well. And everything starts with a simple configuration. All right, so that was the Panda Bot. So now I have a pull request, and right now I have more pull requests. So it may be that it works right now. Honestly, don't know. But however, we have now 7 pull requests open, which means there are version updates happening over here. And the same thing, this is why I use a lot of Dependabot commands, so I can see this ignore this minor version and communicate it. When I do this comment, Dependabot will actually give me thumbs up when it's completed. So right now it's closed, and if I go back, I don't know, 6 pull requests. Quite normal. Okay, so that was the Panda Bot. So in there to the repository, to code security and analysis, enable dependency graph, enable the Panda Bot alerts, updates, and version updates. And this can be done for the public repositories or the private ones with the GitHub Advanced Security licenses. Now we have already seen the cheat sheet, but yeah, so without the Dependabot turned on, the mean time to remediate is 180 days plus. This is for the industry standard, which is quite a lot of time. And with this turned on, we're going down to 40 days. So if you have a vulnerability, just turning on dependency, Dependabot will actually shorten our mean time to remediate to acceptable levels. Of course, these are numbers generally, and they can be different. I have a question over there. Yeah, there are a list of different package managers that can. Sorry. Oh yeah, repeat the question. So the question is if there are any kind of limitations to which dependencies there are. So the Dependabot is actually scanning for the certain dependencies. So npm pip Python, npm Python Maven, .NET like NuGet and so on. So there is a list on GitHub which are supported, and there are some added. So not everything, but there is quite large list. So, all right, let's to the next one. So secret scanning. For, as mentioned, it's really easy. It's quite easy to do a mistake, even with a key vault usage, to just insert a secret in your repository. And once you have done that, it's in there. It's out there, and especially if it's a public one. And for that, the GitHub has secure. It scans for secrets. So it will catch secrets, and there are 2 modes. The first one is it can actually prevent you from actually pushing your code, doing the push to your origin. Or the second is just to actually warn you for it. So you can actually configure it so it doesn't let you push the code into the repository. For the public repositories, there is also automatic revoking. So the GitHub has partnered up with 35 plus cloud providers, which means if they sense that this is a secret that one of the private providers have, they will tell that to the provider. They have API calls, and then they can take decision on their side if it's going to be revoked, or if you're going to get message from the cloud provider or whatever about this breach. And there are other possibilities as well how to handle this. But that's for the public one. For the private one, it's usually kind of up to you to handle that. And if you look at the providers that GitHub has a partnership with, we have Azure, we have AWS, we have Google Cloud, NPM, Slack, and many more. And so those are protected. And out of the box, there are a lot of secrets that it scans for automatically. Now, the secrets that it scans for are really specific. So they don't produce much noise, but they are specific to certain certain partners. And this is something you can change. So basically, you can add up to 100 custom secrets to scan per repository, or 500 per organization. And I will go through, and actually we can get a couple of secrets together and search for our code for that. And there is also possibility for us to test those secrets before we commit to them. Because if you have a big organization and you do this change, once you publish it, it will start searching everywhere, and people will start to get messages from GitHub about the warnings that you have found. So this needs to be tested before you actually push. So let's go back to GitHub and let's turn this on. So once again, security, code, security and analysis, but this time I will enable GitHub Advanced Security, and tells me how many licenses I have. And also I can also see number of pattern. I can turn the code scanning on. I can turn secret scanning on. So let's, this is now turned on. And I see the push protection is also turned on. This is where I can add custom patterns. So either I press new pattern or do it here. New pattern, just let's search for a sign-in. 1, 2, 3. This is regex. So in my case, let's just search for a very specific string. And I can test it just by putting some test code here. Save and dry run. So it has tested my code, and right now I can. It will do a dry run on my code base, and I will get to see the results. No much is found right now, so I will do so that I publish the pattern. Right. So now the pattern is live, which means it will start looking for the sign-in 1, 2, 3, this text string, if I try to commit it in one of my files. And I will do just that, or try to do just that. So go to my README file, just add it here, and commit my changes. And if I go to settings, security, secret scanning, I have this warn me for that. Of course, not everybody can see this. You need to have enough permissions to see that on repository. So so usually administrators of the repository can see the secrets, or persons that you add secret administration on the org level. So there is a group you can create, and you can give those persons access. So you have security champions or people like that in your organization, you can give them access so they can actually see the secrets leaked. In this case, I need to rotate the secrets. So if this was to be, this is password, or I would need to actually go in and revoke it or fix it. But I need to make sure that this actually is secret. So in some cases, this is false positive. This can be something that's just used in test, or that is already revoked, so it doesn't matter. So what I can do here is I can just say it's false positive, it's or just won't fix, and I can dismiss alert. The same thing here. Right now I have 0 open, 1 closed. And if I to add the other ones, it will behave the same way. And once again, settings, code security and analysis, and right here we have a push protection that can be turned on and off. In this section should actually prevented me from pushing that. If we look at the push protection, so what it does is it will, if it finds a security, it will won't allow us to actually push this code to our origin. But we will get the configuration, they will get the message, and we can actually tell GitHub to allow us to push it anyways. So I can override it. So I can say it's used in test, allow me to push that secret, and then I can try to push it again, and it will allow me to do that. So that's secret scanning, and once again, everything is visible in the same way. So in the security, secret scanning, and Dependabot in the same place. Whilst now when I'm here, I can also talk about a couple of things, security advisories and Dependabot alerts. Now, when we do, when we create our applications, we need to make sure that we communicate to other developers on how to approach approach security kind of questions to the owners. How should we raise the security problems, and what is a security policy. So if in the GitHub I can, for policy, ask GitHub to create a boilerplate for me, which is start setup. It creates security MD file in the root, and basically it tells us a couple of things. This is just boilerplate, so this is something I can change. But it tells me, all right, so which versions of my project are you supporting? So if it's like, let's see, so 5.1, it's supported, but maybe 4.0 is not supported. So I communicate with other developers about what versions are supported and what are not supported. And also how to report vulnerability to the code owners, maintainers, owners. So what I will do, I will actually commit this. And if I go to security, I can see now that I have a policy in place. Advisory, this is something that we write up if we find vulnerability in our own code. And this is something that we use to communicate to others that we have found something in our code and you need to update your dependencies to actually have this fixed. So the process here is, if you find a vulnerability and you have fixed it, you will do a new security advisory. You will describe the issue, the problem, which ecosystem, package name, which version it affects, and which version are patched, and you can actually send it to the database. So this is the database with GitHub will use later to make sure that it raises Dependabot will raise vulnerabilities for others that use your package. So this is something that you can write up when you have found an error and fixed an error. So you need to have a version updated for that. So right now the code is good, though I don't have code scanning problems yet. I will create that pretty soon. All right, back to PowerPoint. So third part of GitHub Advanced Security is code scanning. And for that, GitHub uses CodeQL. So CodeQL is open source, and we can use it just in our own applications and use it to scan the code. I have another question from you. Yeah.
Yes, I was wondering if GitHub, the GitHub vulnerability database was the only one, or if it's also comparing against other database like the NVD, for example.
So if you have a CVEs added as well, it will check against those as well. So and this is when we go to, for example, if I have go to advisories, raise an advisory, and if I have one of the codes, vector strings, and CVEs ID, I can use that, and that's one of the database that will look. All right, so the code scanning part. So now we have secured our repositories for secrets. We have secured with Dependabot for the dependencies. Now let's search our own code. So the CodeQL is a static code analyzer, which basically creates a database of your code, of the execution tree, and let you create queries, language queries, how to query those that code. So the first step is just create a database, then you do analysis, and then you actually upload the values to GitHub. And I will go through because this is something that you can do with other tools as long as they support Sarif. And with the CodeQL, what you will see, it's a deep semantic analysis. It will be native to developer experience. You will actually see this together with the code. It will mark down the code in that has the problems, and it will actually describe the problems, how to solve it, why is this a code problematic code, and so on and so forth. And this can be also configured so it prevents vulnerability merging into your master or main branch. The questions, though, so the queries, because this is open source tool, the queries are, there are many queries publicly available. So not only GitHub, but other bigger companies are sharing their CodeQL queries and package them so we can use them. So right out of the box, there are 3 packages that follows with GitHub, but then you have a lot of other packages you can include in your build from the open source community to have it scanned. So CodeQL will just increase, the number of queries will increase, and the protection will increase with that. And this is basically, it's like a bit of an onion. So GitHub powered, we have OWASP top 10, we have SANS 25, we have the most kind of the usual suspects, so to say. Then you have a custom power, which means that our companies like Microsoft, Google, Uber that are actually contributing to the CodeQL. And then you can have a specific CodeQL queries specific to your organization. Which means that you can use them not only to find security threats, you can actually use them to find performance threats, performance problems in this way. And this is something that we can turn on. In most of the cases, it's quite easy. It's most of the languages is just almost out of the box experience. But in some languages, we need to configure that as well. When we configure GitHub Advanced Security code scanning, we don't need to use CodeQL. You can actually choose any of other components to use as long as they can communicate through Sarif, which is a JSON format, standard format for communicating between the systems. So in this case, you can actually use something like I know there is a Sneak is there, and there are multiple tools. I will show you which ones are available. And you can combine them. You can use CodeQL and other tools as well to have a full protection. Right out of the box, we have over 1,700 queries in GitHub, and we have already 20,000 public repositories that have this turned on. And what we have seen, or what we see here, is with those 1,700 plus, 35% of recent JavaScript CVEs would have been identified just with the basic setup. So it's a good number. It's not 100%, but it's still something very significant. And then fixed rate for potential vulnerabilities flagged in open source project is 72%, which means we are shifting left truly this time. So I will go in and turn this on in my application. So once again, the same thing, settings, code security and analysis. And right here, I can turn on setup code scanning. So the first thing it will ask me to do is set up code scanning tool. I will click on that. And here is the list that I can choose from. And this is based on which languages I have in my repository as well. So I want to start with CodeQL, configure that. Now it will generate a boilerplate for me, and it will automatically detect which languages I can scan for, and I can see in the like with the comments which languages are supported. So in this case, it found the C# and JavaScript and can provide a scanning for those. So JavaScript, it scans as usual. If it's find JavaScript files, it will go through them. But for languages that are compiled languages, it will need to do. It will look through just a regular compiling and let compiler do the job, and then analyze later on that. So right out of the box with C# and C#, this is a basic.NET 6 backend. If I just start commit, this will work. So what I get is I get the workflow named CodeQL, which scans for my main branch. It's also scheduled. So even if I don't do some code changes, it will still check it out. And right now I can see that I have this action running. So once run, it will run 2 times. It will run for every single language that I specified. So in this case, C# and JavaScript. It will take some time, but it will run, and it will give me the results in the security. If I go back to code scanning, of course, when this build goes through, I will get my configuration, but I can still add multiple tools. I can still go in and say, I don't know, let's do some Stackhawk or whatever, and right out the box, we're gonna get the boilerplate for that as well. For many of those tools, you will need to have a secret added, some type of key. Let's see if the action continue to run, and during that time we have a question again. Maybe we can
when you open a pull request, does it run on the whole project every time, or only on the portions of the code you modify?
It will run through the code that is in the pull request.
Okay. Yeah.
So. We have another question. Sorry.
So can it scan the workflow? If the developer start to commit a workflow, is it going to scan it or scan code only?
It will scan so if you have a pull request, so it's a regular build, because this is a regular build, it will behave like regular action. So if you do a change, if you don't ignore it, it will scan. But it won't scan the the actions. I don't recall. I need to check that for you. If you mean if the action parts in the GitHub action was scanned as well. I need to check that for you. Right, unsure. So the question also, because this behaves as just regular workflow, it will scan as regular workflow. Now, question was will it scan those as well? Yeah. So I will need to come back on that one. And go back to actions and see. Right, now we are completed. And if I go to security, everything looks good. Now let's introduce an error here. So I have a Visual Studio Code over here, and if I go to backend, I prepared controller, which you can see where I'm going with this. So I prepared with the code that is basically SQL injection. So I opening my code for the input that I pass directly to the database. And I will do this thing. I actually comment in, send it in to code. Commit. And then, oh yeah, I need to do, let me do it like this. So I'll git pull first, so I don't get problems. And I will select it. Okay, perfect. So I have this code sent in to my origin, and I should see a build going on. And if I go once more now with code scanning completed, I can see a different view here because it have found CodeQL scanning, and it tells me it's 118 rows scan and duration, yada yada, and everything looks good. But right now, when this action has completed, it will warn me for the problem that I have introduced in my code. And here you can see I can still add other scanning tools for scan. During time this build goes through, I can actually go and cover the overview. Everything I show you, it was repository centric. But in some cases, we want to see what is the situation on organizational level. So maybe I have a couple of hundred repositories, and I need to check what is the status on those. And there is a view, there is security overview on the organizational level that actually can present us with the number of risks we're having, the number of repositories with GitHub Advanced Security enabled. We can see the number of alerts, which alerts do we have, and the statistics like that. And this is a great way for us as a security people to actually get to know our organization better. Now we have this Solidify demo, and I go to settings, I can go to code security and analysis. And these are the configuration I can do, but on the organizational level as well, I can go to security, and this is the overview version of it. So right now it's just demo repository, so we use this for demos, which means that a lot of code scanning and secret scanning will not return results. We have some famous repositories in here. We have WebGoat, and you can see there is 11 code scanning and certified Dependabot problems like in OWASP WebGoat. And over here we can see the Dependabot warnings, which ones are critical. We can filter on them. We can see which repository it is it warns for. We can see the code scanning wise as well, which errors do we have in our code, and secrets as well. So in many cases, this is just a test. But for your organization, if you have this type of access, you will see everything. So it's you need to limit visibility to right set of people, and also you need to manage those warnings in a good way, because I mean, if you have 42, it's not really good, especially if you have more than that. Let's go back and see now. I should have a couple of more security warnings, or one more security warning. Right. So I have code scanning, I have SQL injection, it warned me for, and I can see it in the code. It will mark the code that introduced this vulnerability. I can see the documentation or recommendation. I have examples, references, how to fix, and so on. So it makes it really easy for the developer just kind of to understand what the problem is and solve it. We have a question in the back. Davis is doing squats here, up and down all the time.
So the question is, does it like play well with Copilot as well?
Play well with Copilot. I have a Copilot colleague here.
Okay.
So
I'm not a Copilot expert, but Copilot and it's two completely different things. They run together, but Copilot doesn't do anything with GitHub Advanced Security.
So the good question, I can take it with me and I can write it up somewhere and share it with. So I have two questions I need to get back to you with. And as well, I can create an issue here or just dismiss it if I want fix, or I will do a fix, and once I fix this, the tool will close code scanning for me. So it will close the vulnerability once I fix this on my own. So if I comment it out or change it, it will actually close this vulnerability for me. So that's it. And if you look at the holistically, the biggest benefit here, as I see it, it's where we work every day. It's the same tool. It's where we do pull requests, where we code, and this is actually a tool that will kind of help us with this experience of shifting left. It's native to the dev environment and in many cases automated. I think that's everything from my end. Do we have any questions from the chat? No, nothing on your end?
I've got a couple of questions.
Yeah, go ahead.
First of all, I was just thinking about the generating the advisories. Is there any way that GitHub can check the quality of these advisories? I mean, it's well known that people sometimes kidnap, say, an NPM repository.
Yeah.
And normally, if I inject malicious code in that NPM repository, I would have to wait until people manually see that there's a new version and perhaps update their version or download the latest version. Whereas now, once I kidnap that repository NPM, I can put in the malicious code, generate an advisory, and I know that there'll be a load of people running GitHub security which will then automatically generate updates and new builds.
I know there are reviews connected to the advisories, so there is some protection there. But still, kind of, if you lose access to the repository, if somebody else gets it, it's really hard for anyone to actually determine if you are it's that it is correct or if you get hijacked.
Yeah.
So you still have this circuit, but there is a manual review as well on the advisories, the quality of those.
That's great. My next question was about secrets in the repositories, and I think the push protection is fantastic. But if that's not in place, now if I send in a secret like a password, that's fixable because you can roll out a new password.
Yeah.
But if I send in a secret that's not changeable, biometric data, fingerprints, social security number.
Yeah.
Do you have any advice? Because once that check-in has taken place, it's in the history for the GitHub repository. Is there any? Do you have any suggestions about how you can purge or clean up?
Yeah, there are tools for purging. They are destructive though, so there should be careful with that. So there are tools actually that can go in and change the history of your code. So actually you remove but they are I can put in the name of the two tools that you can use for that, but they are destructive, so careful with those. They will change the repositories for you. Other than that, push protection is a good way to secure it. Not really sure. I almost had a glance. I think we're out of licenses. Could be that. I think that was the issue. So the push protection will actually, if you have this as a custom, it will block it. It will not allow it to actually enter the code.
And my final question was about this code analysis.
Yeah.
For example, your example you gave there of SQL injection.
Yeah.
If you've got a backend method which allows SQL injection, that's not good. But
yeah,
it's even more terrible if the inputs for that method actually go all the way up to some, say, untrusted input field in the.
Yes. I think we lost you on the. Our batteries? Yeah.
Hello? Hello?
No, it works.
Okay, so I was saying that if you've got a possible code injection in a background method, that's bad.
Yeah.
You've got variables, but it'd be even worse if those variables, you can trace them all the way to some input, untrusted input field in the GUI.
On this, it's almost AI triggered now. Yeah. All right. So the question, if they can track it all the way to the input field, so it's if it's in the same solution, it can. But if you, like me right now, I have a React and .NET, it won't. So in this case, it will have an API, and you need to trace. Yeah. So yeah. But if it can track it in the same solution, if it is .NET all the way, it could be able to catch that. We have another question. Yeah. So the question was if there are any differences between the open source part and the enterprise part of the GitHub Advanced Security. So if you buy a license, you get the full suite where you can do custom secret scanning and so on. Like in public one, you won't get that. So you won't be able to do organizational level stuff. You won't be able to see. You will see it on a repository level, and also, to my recollection, is the secret scanning part as well. You can't do custom. Yes. So this was the enterprise level setup, and I'm pretty sure that we are out of licenses, which is why that the thing messed with me. So let's see where I'm at right now. So it for the licenses, it's no, we should have more. So it's active users in last 90 days. So this is how it calculates the licenses. So the committers in the last 90 days, that's used as one user. So if you have a dormant user that didn't do any commits for a year, that they're not counted. All right. That's everything from me. Thank you very much. All right.